Okay, it's time to start graphing linear inequalities of two variables. Up till now, we've dealt with inequalities and just had one variable to worry about, and so we could graph those on a number line. But because we have two variables now to worry about, we need to have two axes, which gives us a coordinate plane to graph on. And instead of having multiple points on a number line which satisfy a condition, we're going to have multiple points on a coordinate plane which will satisfy conditions to this inequality. So the first thing I notice is that on this inequality, it looks very, very similar to what I've seen before in terms of linear equations. So I have a y-intercept and I have a slope. And because I have those two things, I can graph what's called a boundary line. Now, I'm going to graph the line y equals negative 2x plus 3, and that's going to be my boundary line for this inequality. And it's going to separate the plane into two halves. One of those two halves is going to hold all of the solution points that satisfy this, and one half won't. Now, I need to be careful because I just can't graph the line. I need to be aware of my boundary line, whether it's a solid line or a dashed line. And this symbol is going to tell me which of those two I have. Remember when we graphed on a number line, if it was less than or greater than, I used an open circle. Well, if it's less than or equal, or if it's less than or greater than in terms of the coordinate plane, I'm going to use a dashed line. And that's how I'm going to emulate an open circle. So I notice on this one, I have just a strictly less than. I know my boundary line is going to be dashed. I'm going to graph the line y equals negative 2x plus 3. So the y-intercept is 3. The slope is negative 2, so that means from that point I come down 2 and over 1. And I have 2 points which define a line, and I'm going to draw my boundary line. In this case, it's going to be dashed. So right now I have two halves to my coordinate plane. I have this half over here and this half down here. And one of these two halves is going to contain all of my solution points. The other is not going to contain any. What I like to do, some people will tell you that the inequality tells you whether to shade below or above. I think oftentimes it's more applicable to things coming down the road if we just pick a point and test it and see if it makes this inequality true. And the easiest point to always grab and test, unless your boundary line goes through it, is the origin, because the coordinates are 0, 0. So I'm going to test 0, 0, and I'm going to see if they make this true. If they make this inequality true, then I'm going to shade on that side of the line. If it makes this statement false, then I'm going to shade on the other side. So I want to know if I plug in 0 for y and 0 for x, does it make a true statement? Well, 0 is less than negative 2 times 0 is 0 plus 3. Is 0 smaller than 3? And the answer is yes, that's true. So this point satisfies this inequality. So I'm going to shade on this side of my boundary line, because every point on this side of the boundary line is going to satisfy this inequality. So let's try one more. I just noticed that I had put this equal sign in, so I've crossed it out. Okay, so I've got y is greater than or equal to. So in this case, because it has the equal to part under it, my boundary line is going to be solid. I'm going to graph the boundary line y equals 2/3 x minus 1. So I look at that and I know my y-intercept is negative 1. The slope is up 2 and over 3 from that point. My boundary line is solid. I'm going to test the origin to see if that point works. So I ask myself, is 0 bigger than or equal to 2/3 of 0 take away 1? Is 0 bigger than 0 take away 1? And 0 is bigger than negative 1. So again, this point works. So it's part of my solution set, and I can shade there. Now, some folks are going to say this is greater than, you shade above the line. This is less than, you shade below the line. I want to show you an example where that isn't necessarily the case. So here's an example of a linear inequality that is in standard form. It's not in slope-intercept. And I'm going to notice the inequality is less than. So, you may think we have to shade below the boundary line. Let's see if that's the case. So the easiest way to find 2 points to define my boundary line is to find the x and y intercepts when written in standard form. So to find the y-intercept, I'm going to plug in 0 for x. Let's see, 2 times 0 is 0. I end up with negative 3y is equal to negative 6. Well, my y-intercept is 2, because that's what would make that statement true. To find my x-intercept, I'm going to plug in 0 for y. So essentially that's gone, and I'm just wondering 2 times what makes negative 6? And it'd be negative 3. So negative 3 is my x-intercept. It's just a strictly less than. There's no or equal to, so I'm going to make a boundary line that's dashed. And again, I'm going to test the origin. I'm going to plug in 0 and 0 for these two and see if it comes out to be true. So it is 2 times 0 minus 3 times 0. Is that smaller than negative 6? Well, 2 times 0 is 0. Subtract 0 is less than negative 6. Is 0 smaller than negative 6? And the answer is no. 0 is actually bigger than negative 6. So this is not part of the solution set. So that means I need to shade on the other side of the line. I'm going to shade up here. And here is a clear example where this was a less than symbol, but I didn't shade below my line. So the easiest thing to make sure that the shading is correct is always pick a point, plug it into the inequality, test it, see if it's true or not. If it's true, you shade on that side of the line. If it's false, you shade on the other side of the line.